Okay, we're looking at homework from section 4.3. It's question number 6. Find the indicated probabilities using the geometric distribution, the Poisson distribution, or the binomial distribution. Then determine if the events are unusual. If convenient, use the appropriate probability table or technology to find the probabilities. A newspaper finds that the mean number of typographical errors per page is 5. Find the probability that A, exactly 6 typographical errors are found on a page, B, at most 6 typographical errors are found on a page, and C, more than 6 typographical errors are found on a page. In part A, we need to first determine what kind of distribution this is. Since we're looking for the number of errors per page is an area of space. We're trying to find the number of occurrences in a given interval of time or space. That makes this the Poisson distribution. So to use the Poisson probability formula, we need to know the value of mu. It says the average number of errors is 5, so that's our mu. And then in part A, the x value we're looking for is 6. Our Poisson probability formula looks like this. The probability of x occurrences is mu to the x, e to the negative mu, over x factorial. If we put these numbers in the correct positions, that's going to be 5 to the 6th power, e to the negative 5th, over 6 factorial. We plug this into our calculators. We get 0.1462228081, rounded to 4 decimal places, is 0.1462. That's your answer for part A. In part B, the probability that at most 6 typographical errors are found on a page, we're going to turn to technology here. Okay, we're going to look at the TI-8384 graphing calculator, because otherwise what we'd have to do is something similar to what we just did for part A, but we would have to do it for all the values for x from 0 to 6. That's 7 different formattings for that particular formula. And to save ourselves some work, we can use a built-in function on the calculator. Now, there are 2 versions of the calculator, and I'm not talking about the TI-8384. I'm talking about within the TI-83 and 84, there are newer versions of the TI-83 and 84 and older versions of the TI-83 and 84, which have slightly different software. So you will see some differences depending on which calculator you have. So I'm going to go through both different types of situations here. Lucky for us, they both start the same way, by pressing the second function button and then the vars button. Once we do that, we're taken to the distribution screen. Because we're looking at a Poisson here, we're going to scroll down to Poisson CDF. Whenever we want to add several values together, we always turn to a CDF formula. So we scroll down to where it says Poisson CDF, and we press enter. And this is where those 2 versions of the software diverge from one another. If you have the older version of the software, what you'll see is Poisson CDF will show up on your home screen, followed by a parentheses. And it's your job to fill in the rest of the formula. To fill in the rest of our formula here, the first thing that we're going to do is type the mu value, which in this case was 5. Then we type a comma. Then we type in the x value for this problem, which is 6. And then we end it with a parentheses. Now, why is the x value 6? When you're using a CDF function, that means you're adding several values. And the Poisson CDF always starts by plugging in 0, then it plugs in 1, and it plugs in 2, and it plugs in 3, and it plugs in all those numbers one at a time up until the number you tell it to stop at. So we're telling it stop at 6. So we want it to plug in 0, we want it to plug in 1, and 2, and 3, and 4, and 5, and 6, and stop at 6. And then add all those values up. So then we press enter, and what we'll get is 0.7621834631, rounded to 4 decimals is 0.7622. And that's your answer to part B. Let's look at how the newer version would look. On the newer version, once you were on the distribution screen and you scroll down to Poisson CDF and pressed enter, you would be taken to this screen, the Poisson CDF screen. There's a Greek letter lambda there, the x value, and paste. Where the lambda goes, you're going to type in your mu value, which is 5. Where the x value goes, you're going to type in the 6. And then you're going to highlight the word paste and press enter. And the same thing will happen. You'll be able to see the 0.7621834631. You may have to press enter one more time to get that, and round it off to 4 decimals. It's 0.7622. And again, that's your answer to part B. So let's look at part C. In part C, we're looking for the probability that more than 6 typographical errors are found on a page. We just found the probability that 6 or less typographical errors were found on a page. So this would be the complement of part B. It would be 1 minus the probability that there were at most 6 errors. So that would be 1 minus the 0.7621834631 value that we got in part B, which is 0.2378165369, rounded to 4 decimals, is 0.2378. That's your answer to part C. The last question is, are any of these unusual? And remember, our criteria for unusual is that the probability had to be less than 0.05. And if we look at all of these probabilities from part A and B and C, none of those were unusual. None of them were less than 0.05. And so the correct choice for the last question is D. And that's your answer.